Okay, we're doing some worked examples on differentiating polynomials, and these examples are all based on using the result that if f of x is of the form ax to the n, then f dash of x is an x to the n minus 1. Now this result works for all values of n, both negative and fractional. Now there's some examples that you need to be aware of, some different ways of handling each of these types of expressions to differentiate them. So the first example, if we have something like f of x equals 2 over x cubed, we can't differentiate that in its current form, so we need to make it look like these expressions ax to the n. So using our negative indices, this is 2x to the negative 3. Now we can differentiate it. Multiplying by the power, we get negative 6. Taking 1 off the power, we get negative 3 minus 1 is negative 4. So our derived function is negative 6x to the minus 4. The second type of function we get, which we have to alter slightly, are things like this. Maybe the square root of x divided by 2. So we have to alter this a little bit before we can actually find the derived function. The square root of x, if you recall, is x to the power of a half, and the divided by 2 we can just leave down there, or we could write it as a coefficient of a half. Now we can differentiate this, g dash of x. The divided by 2 is fine, we can just leave that alone and ignore it. The x to the half goes to a half, x to the negative a half. Half minus 1 is negative a half. And we could simplify this once we've got that far. A half divided by 2 is actually a quarter, so this is x to the negative a half over 4. The other type of example that we get is things like this, where we've got a product. So we might have x cubed times 2x minus 4. We can't differentiate this as it currently stands. We need to expand that bracket first. So expanding the bracket gives me 2x to the 4 minus 4x cubed. Now we can differentiate this. It's two polynomial expressions like these up here. So this becomes 8x cubed minus 12x squared. The other type that you will meet involve division. So if g of x is something like 3x squared minus 4 all over x, in that state there we can't do anything with that, we can't differentiate it as it stands. We need to split it into two separate fractions. So this first fraction becomes 3x, well, let's do it in more steps. 3x squared over x minus 4 over x. Then we can simplify each of these pieces. This becomes 3x. This one we need to write with our negative index, so it's 4x to the negative 1. And now we can actually find the derived function of these ones. So this is 3x goes to 3. This becomes plus 4x to the negative 2. Now if we wish, we can put it back into the format that it was given to us. So this becomes 3 plus 4 over x squared, putting it back with positive indices.